So good afternoon, everybody.
Good afternoon,
Good
sir.
afternoon, sir.
Good afternoon, sir.
Okay, uh, is my slide? Are you able to see my slide?
Yes, sir.
Okay.
Yes, sir.
Okay. So thank you for your response. Today's lecture will be on continuation of that power flow only, power flow control. We have seen how to control the power flow using series capacitor. Then we can use that TCR and then combine with capacitor, and then we have seen that how we can control the power flow. Okay, so today we will see another ways which method. Okay, so another method to control the power flow. Okay, so that method so is phase shifting transformer. Okay, so using phase shifting transformer, we'll see how we can control the power flow. Okay, so this all we have learned last lecture. Okay, so first we have learned about the basic of power flow, what is meant by power flow, and then why we need a power flow control. Then after that, we have seen one method to control the power flow is using this compensation, series compensation of the lines. And then alternatively, the series compensation can be modified and make into TCSC, terrestrial control series capacitor, compensator. You know that how we will. Okay, so and then all the characteristic waveform will be you will learn in the power electronics application. But here we have seen how it this device TCSC can control the power flow. Okay, so in power electronics application, so all basic theory and then all how it look work has might have been studied there. Okay, work here means it's not working of this controlling the power, just working of this TCSC or characteristic of TCSC might have learned. And then towards the end, so your model tutor might have said that it will be used for controlling the power flow. So like this you might have learned. So now here we have learned how we will control the power flow. Okay, so and another method we have seen is using this DC to AC converters like VAC. Okay, this all we have completed. So today we'll see on phase shifting transformer. Okay, so here when we learn about the phase shifting transformer, so here we will not learn the characteristic of this transformer and then winding of the transformer. Okay, so we will not learn this all you have learned in the machine. And then all in machine you might have learned that in transformer there is primary and secondary winding, and then you will know when we will call it as a step up transformer, when we will call it as a step down transformer, or you will also know by seeing at the number of turns in the primary side and secondary side, you will know either this transformer is a step up transformer or step down transformer. So such type of thing it will not learn in power system operation and control, but in power system operation and control, so we assume that all the characteristic, all the working principle, okay, all the working principle of this device, example, phase shifting transformer or transformer, we assume that you have learned and then you know that. But in power system operation and control, so we will use this device to control the power flow or change the power flow. So now today we will see phase shifting transformer, how this phase shifting transformer will be used to control the power flow in a power system. So this is basic aim of our module. So here, so some of you might be misunderstanding that when somebody say about the phase shifting transformer, so you might be thinking that, sir, I will be explaining detail about the phase shift transformer. It's not like that. Here only the application part of the phase shift transformer will be taught here. Other working principle on then construction and everything you have learned in the machine, or you might have learned in some other module. Okay, so this is just an application of what you have learned in the earlier module. Okay, so now come back to phase shifting transformer. So how this phase shifting transformer will be used to control the power flow or change the power flow in a transmission line. Okay, so actually this phase shifting transformer is another method of changing the power flow through a transmission line. Okay, so it's another method. So first method you have seen is series compensation. Okay, under series compensation, again we have classified that TCSC can be used, right? Then again we have seen that VSC can be used. Okay, so today we are seeing the phase shift transformer, and then it is another method of changing the power flow through a transmission line. And after completing this phase shift transformer, so you will be able to know the differences between series compensation or using capacitor and then phase shift transformer. Okay, what they will do, actually both will change the power flow, but after completing the phase shift transformer, so you will know the exactly the differences between. Okay, so now this phase shift is another method of changing power flow, and how it will change the power flow is this phase shift transformer or phase shifting transformer. Okay, so we will try to introduce a small phase shift. Okay, so a small phase shift in a voltage, okay, at its two terminal. Okay, so which means normally when we talk about the transmission line, we are talking about the three phase line. So which will have line voltage VA, VB, and VC. Okay, so that what we will do is we'll try to introduce a small phase shift in the voltages. Okay, so VA, VB, and VC by injecting a series voltage. Okay, so we'll try to inject a series voltage in a transmission line, and then we'll try to introduce a small phase shift. Okay, so with introducing this phase shift, so it says power flow in the transmission line will change. How? So we will see. Okay, so but how we will control the power flow or change the power flow in a transmission line is one way is using a phase shifting transformer, or we call it as a phase shifter. So this phase shifter will introduce a small phase shift in the voltage and at its two terminal by injecting a series voltage. Okay, so what it means is you can see here clearly, so I will explain with this diagram. So now a three-phase system, it will have VA, VB, and VC. Okay, so line voltage VA, VB, and VC, and then so by to change the power flow in this transmission system or transmission line. So now one method is we can use a phase shifting transformer. Okay, so here we can introduce a one phase shifting transformer, and then what it will do is this phase shifting transformer will introduce a phase shift. Okay, phase shift or a small phase shift, and then at this terminal you will not get the same voltage like this. There will be, you will get a same voltage, sorry, but there will be certain deviation, means phase shift will be occurring there. So that's why it has been written from, let's assume this is a sending end and the other one is a receiving end. So from sending end we are sending the VA voltage, okay, VB, VA, VB, and VC line voltages. But when you reach at the receiving end, so you will not get the exact VA, VB, and VC. So magnitude you will get the same, but your phase shift will change. Okay, so phase angle will change. You will not get the in phase voltage here. So what you will get is, so here you will get a voltage VA1. I have denoted by VA1, which means there is some phase shift in created by introducing this phase shift transformer. Okay, now this is a block diagram, and then if you go through the phasor diagram, so you might be knowing how to draw a phasor diagram. Okay, so this phasor diagram, so you will get this type of phasor diagram. Okay, I have drawn only for a one. Okay, so you can draw for this VB, even VC also, but it's okay if you know the for one, the concept will remain same. Okay, so now what you can do is this, actually these are the original voltage VA. Okay, okay, so then what you have done is by introducing this phase shifter or phase shift transformer, so you will have a one phase shift let's say that it be theta. It has been phase shifted by angle theta, and then you are receiving a voltage is V1A. So which means there is a delay or lagging here, right? By phase shift by angle theta, and this is actually ascending end voltage VA, and then you will get a VA1. How you have got VA1 is because of the introduction of this phase shifter. And then these two difference is a V1BC, because why we are writing V1BC here is because we have introduced the phase shifter at the two terminal here, that is between the line voltage VB and VC. So that difference, these two will be a V1BC. Okay, so this is known as a positive phase shift. And similarly, okay, so positive phase shift or just theta as shown here. And then similarly, you can also introduce a negative phase shift here. Okay, so similarly, a phase shift of negative theta can be obtained by reversing the injection voltage, because what we are doing is here we are trying to inject a small amount of voltage. Why we are injecting here? We are injecting to create a phase shift. Why we are creating a phase shift? This is to control the power flow in this transmission line, which means we don't want a whatever power we are sending from here to be received here. So which means we require some changes in power in this transmission line. So that time, if we require, then we can introduce this phase shift transformer. Okay, this is one method which we can do. Okay, so now with mathematical derivation, little bit of mathematical derivation, so we'll see that other one is phasor diagram and a block diagram I have shown. So now for this one, let's assume this is our normal transmission line, which has okay, two branches. One is okay, having an inductant reactant X1, and another one is having a reactance X2. And then we assume that here at descending end, your voltage is V, and then your angle is theta, delta 1, and then you have a receiving end voltage is same. You're getting same voltage V, and then angle theta 2. Okay, so this is a normal transmission line. Let's say through the reactant X1 power P1 is flowing, and then through the reactance X2 power P2 is flowing now. Now V1, okay, so there should be a regulation of control of the power flow in. Let's assume that the power flow control of power flow in line 2. Okay, so now how we can control is, so now we can introduce one phase shifter, means phase shift transformer. So here I have just connected phase shifting transformer in series with this reactance. Okay, so just this is a block diagram. Okay, so that I have connected in series. So if you are connected in series, so which means we can change the power flow in this line 2. Okay, so we can change the power flow in line 2, and then our intention here is we are trying to change the power flow in line 2. So originally your power flowing in line 2 is P2. So now after introduction of phase shifter, so now you will have a new power flowing in the line 2, that is P2 new. So let's keep it as a P2 new, and then here what we have is same as original one only, V angle theta 1, but after introduction of phase shifter, so you will have the same voltage but your phase angle, so let's assume that positive phase shifter has been introduced, so you will have a phase angle difference. Okay, so by theta del 1 plus theta, which means we have introduced a phase shifter which will introduce a small phase shift by angle theta, and then here receiving end, so we will remain same. Okay, so which means for this network, okay, so total power sharing by this network will remain will be given by this P2 new by P2 new plus P1. Okay, so this is a total sharing of the power between these two lines, so you will get P2 2 new divided by P2 new plus P1. Okay, so now this one can be in two lines, or total power sharing in these two lines will be altered by introduction of phase shifter. So that's why you have written P2 new. So earlier one, you will have P2 divided by P2 plus P1 only. So now what we have got is, instead of P2, you are getting P2 new because of this phase shifter. Okay, so because of introduction of phase shifter, so power flowing in the line 2 has been changed to P2 new from the P2. So now, similarly, earlier one, what you will get is P2 will be equal to, so you will get, since both side sending end as well as receiving end voltage we have denoted by V, so we will get V square sine del 1 minus del 2 by x2. Okay, so this power P2, so in original one, without the introduction of phase shifter, so you will get P2 will be equal to V square sine del 1 minus del 2 divided by x2. But with introduction of phase shifter, so this power P2 new will be given by, so now here we cannot take this one because you are sending in voltage through transmission line 2 has become V sine del plus theta. So now in such case what you will get is P2 new will be equal to, say, here voltage magnitude is remaining same, so that's why you will get V square and then sine delta 1 plus theta minus delta 2 divided by x2. So now your earlier power P2 and the new P2 is a difference of this phase shifter. Okay, so power flowing in the line 2 will be determined by this theta, value of the theta. So earlier we don't have a theta, so now you will get this power, and then with the introduction of phase shifter, so now your power flowing in the line 2 will change to P2 new, and it will be given by V square sine del 1 plus theta minus del 2. So now it will depend on this value angle theta. Okay, so power flowing in this transmission line 2 will depend upon the angle created by this phase shifter. So similarly, you can also do for a P1. You just introduce here phase shifter, and then you can see that power flowing in the transmission line 1 or line 1 will also get changes. Okay, so this is how we will control the power flow in the transmission line using phase shifter. Okay, so you try to change the phase angle or try to create a small amount of phase angle, and then you regulate the power flowing. This is known as power flow control. Okay, so this is how we control the power flow using a phase shifting transformers. Okay, here please be mindful that, so we will be not talking about the construction of the phase shifting transformer and all. Only thing here we are studying is the application of phase shifting transformer. So now application of phase shifting transformer. So if you want to change the power flow in the line 2, so example I have given here. Similarly, you can do for line 1 also, but line 2, I have given example for line 2. If you want to change the power flow in line 2, so we assume that after introduction of phase shifter, power flowing in the line 2 is P2 new, and earlier it is only P2. So then power flowing in this transmission line P2 will be given by V square sine del 1 plus theta minus del 2 by x2 is reactant. So this is how we can control the power flow in the power flow using the phase shifter or phase shifting transformer. So you know why we got this power P equal to, actually you might have learned as a power flowing in a transmission line is equal to EV sine del, right? So from there we have started this, and then we have seen the receiving and ascending end angle and the receiving end angle, and then we have introduced a phase shift, and this is how we get the, or how we can control the power flow or regulate the power flow in a transmission line using a phase shift transformer. Okay, this is very simple. Okay, so here we are only carrying out about the application part of the phase shifting transformer. So now with this example and then with this graphs, I will explain the differences between the phase shift transformer, and then series capacitor you are using. Okay, so which means controlling the power flow using phase shift transformer, and then another one is just series capacitor. Okay, so now both are used for controlling the power, but there is a differences. Okay, some difference are there, but so now first let's forget about this blue color and then red color line. Okay, so we will not see these two line. First let's assume that black color line only. Okay, so this is a just graphical representation of, okay, so power flow versus delta 1 minus delta 2. Okay, so PE versus electrical power flow versus uh, angle. Okay, so which actually this type of graph is used for the stability analysis. Okay, so now let's forget about the red color and then the blue color line. First see what initially, so see here it will start from here and your power flow. Okay, that, okay, so now and similarly it will start like this. Okay, so for one half cycle, for half cycle I have shown here, so your power flow like this. Okay, then if you really want to, now next is if you want to control the power flow, so now there are different ways which we can control the power flow. So first let's consider using a series capacitor. Okay, so first using a series capacitor, so you can control the power flow. So theory part already you have learned. So now initially you have this black color one. Okay, this is a power curve. So now when you use a series capacitor, so what you will get is, so you will control the power flow, but here you see that this red color line, okay, this one, red color line. So your power flow key, what it happen is when you use a series capacitor, so now or series compensation, so your power flow will be controlled, but how it control is, so your power increases from the initial power flow. Okay, so see here there is an increase in power flow, which means maximum power flowing in the circuit will increase by using a series capacitor. So when you have to use this type of compensator, so now you know that characteristic, maximum power transfer can be increased by using a series capacitor. So now when you have a low power, if you get a low power at the receiving end, then you try to use a series capacitor and then increase this power, which means we are trying to inject the reactive power and in improving the voltages here, right? Okay, so now another case is, so now what you can see is, so now this blue color line, so in this blue color line, so just we are using the phase shifting transformer. Okay, phase shifting transformer. So when you use a phase shifting transformer, so we are creating some phase shift by angle theta, and then we are trying to control the power. So now in this case, when you use a phase shifting transformer, so you will not see any difference in the maximum power. So maximum power will remain same with the initial power only, but what it will do is it will regulate the power flow, or it will control the power flow, which means, so now sometime you require a power maximum power at let's say time 1 to 2. Okay, so then you create some delay and then create such a way that this maximum power you will get is at time 2 to 3. And then similarly, if you require minimum power, so now you try to see here all this here, right? So it is starting from 0 and then increasing. So now here you can just play with this phase shifter and then control the power flow. So if you want a maximum power or more power, so that time you try to adjust such a way that your phase angle will, okay, so you have a maximum power flow. Whereas in series capacitors you cannot do this. So which means you will get the maximum power, at the same time you will increase the maximum electrical power from the initial one. So that when you will use this, when you get uh, minimum power and then you require a maximum power, so that time so you have to use a series capacitor. But here by using a phase shift transformer or phase shifting, so just create a, and then you can regulate the power flow. Okay, so this is how we can control the power flow. There are different techniques which we can control the power flow. First one is series capacitor, second one is a phase shifting transformers. Okay, so I have explained about this one. So all this I have explained that phase shifter does not change the maximum value of electrical power, unlike series capacitor. So but series capacitor in capacitor connected in series with a line can increase the maximum value of power, and it does not cause mass shift. Okay, so it will not shift here, but whereas phase shifting transformer, you create a phase shift and then you try to shift the power flow here. Okay, this is a different ways. Actually, both are controlling the power flow, but their technique is different or mechanism is different. One will try to increase the maximum power, and another one will just shift the power flow. Okay, so this is the differences between phase shift transformer and then series capacitors. Okay, so which both are controlling the power flow, but one is just regulating, another one is trying to increase the maximum value. Okay, so that's about the phase shift transformer. Okay, so then another ways of controlling the power flow is AC, DC, and AC conversion. So which now we are going a little bit towards the HVDC. Okay, so nowadays, so now HVDC is becoming famous. Okay, so AC to DC, DC to AC conversion can also control the power flow. But here, when we talk about the AC to DC and AC conversion, we are talking about the power electronics devices. Okay, application of the power electronics device. So first, let's see, power flow can also be controlled by converting AC to DC by thyristor bridge or voltage source converter, and again back converting to or reconverting the DC to AC at another bus, again by the same means first normally generation you might have seen as AC only. So this AC has to be converted to DC for transmission, and then when you require at the load side, so normally we require AC. Most of the time you will not find DC load, most of the time we will get the AC load. So then again convert back to the AC and then supply to the load. So using this technique also we can control the power flow. Okay, but here, okay, here you have to know that we are employing this power electronics device. So when you employ the power electronics device, cost will be higher. Okay, so but let's see, this has certain benefit also. So now power flow can be controlled by using this AC to DC and AC conversion. Okay, so DC to AC conversion back. Okay, so actually this type of converter connected in shunt with the AC transmission system at the buses. Okay, so which means you will connect this type of converter in shunt with the AC transmission system, and then normally this type of conversion is used for a longer distance only. Okay, so longer distance, which means substantial distance between the two buses is involved. So that's why Bhutan, they are not going for this type of uh, conversion system or a power flow control, because we don't have a substantial distance, which means here substantial, I have mentioned substantial distances, but it says if it is more than 500 kilometer. Okay, so most of our transmission system will fall in the short transmission line. So that's why we can use in the short transmission line also, but cost involved will be much higher. Okay, so that's why it has been not used particularly in Bhutan, but this is a application. Okay, so how we can use a power electronics device, and then this power flow is a function of converter firing angle. So now based on your converter firing angle, if you use a thyristor, based on this firing angle and particularly, so independent of voltage, phase angle, frequency at either end. So which means your power flow will directly depend upon your firing angle. Okay, so converter firing angle. So I will explain with here with this diagram. So in this diagram, you see that system 1 is here and system 1 AC, and then system 2. So let's assume that it is at the load end and here generating or sending end. So normally here power generated is in the form of AC. Okay, so now to convert to DC, what we require? Some power electronics device. So that power electronics device is, so let's say we thyristor. Okay, and then this one is call it as rectifier, right? So AC to DC conversion is known as a rectifier, and then you will transmit here not the AC power, you will transmit the DC power. Okay, but when we reach to the load or system 2, we require a AC. Okay, normally load will be AC. So then what you can see is, so now you employ another power electronics device that is known as a, we call it as an inverter, which means its function is to convert from DC to AC. So inverter, and then this is how we can transfer. Okay, so which means in the DC transmission system, it says there are less losses or no losses of power. So that's why they are going through the DC. But for a short transmission line, what it says is cost involved for these two devices will be much higher than the cost involved for employing or for this converter. Okay, rectifier and inverter is will be much higher than the profit you will get from here. Okay, so that's why for short distance it has been not gone, not used this type of conversion or power flow control. But what they use is, okay, so for a longer distance, so it says minimum should be 500 kilometer between two buses. So if it is more than 500 kilometer, then we can employ this one, which means it will be a cost effective, it says. Okay, so this is how we can control the power flow. Okay, so using AC to DC and DC to AC conversion. So in system 1, so see here, AC generated, and in system 2 we need the AC. So but let's assume that it is a long distance, and then when you convert, when you transmit the power for a longer distance, it is better. Okay, it will be much better or cost cheaper to transfer using a DC line. So now how we can do is, so now generation will be always AC, right? Except other photovoltaic and all. So AC. So now in AC, we have to convert to DC using a power electronics device. Again, at the load side, we require AC to convert this back to the uh, AC, and this device is known as an inverter. And then when you convert from AC to DC, it is known as a rectifier. And power flow can be controlled by controlling the firing angle of the thyristors. Okay, so now just control this, the firing angle of this thyristor, and then how much power can be flow in this line will be controlled based on the firing angle. Okay, so this firing angle. Okay, so this is how we can control the power flow using AC to DC and AC DC AC conversion. Okay, so that's the basic of the our lecture on the power flow control. So we have learned about how to control the power flow. So under that we have learned first by, okay, so first ways to control the power flow is, okay, using series compensation of the line. Okay, so under series compensation, again, you use a different combination. So we use the TCSC, that is thyristor control series compensator. You use this and then control the power flow in a transmission line. And another one is we can also control the power flow in a transmission line by using VSC, that is DC to AC converter. And then, okay, so voltage source converter, we can use that and then control this. Then another way is to create a phase shift or using a phase shifting transformer. And then main difference between phase shifting transformer and a series capacitor is a series compensation of the line or using series capacitor is in phase shifting, so your maximum power will remain same, it will not alter, whereas maximum electrical power will change in the series capacitor using series compensation. But here in the phase shifting, so you create one small phase shift and then you try to regulate the power flow. And then another way which we have learned is AC to DC and AC conversion. Okay, so these are the different ways which we can control the power flow. Okay, so before we end up for today's session, so I have prepared a little bit on the HVDC link, so we'll see that and then we'll wind up. But HVDC link already you have learned. Okay, some of you have already learned the HVDC link. So, but just we'll see little bit concept on the HVDC link and then we will wind up for today's session. Okay, so first, so already you have learned about the HVDC link. Okay, so HVDC links. So there are different types of HVDC link. First one is mainly there are three types of HVDC link. First one is monopolar, second one is bipolar, and the third one is homopolar. So already you have learned how this characteristic of HVDC link in the power electronics or power electronics application. But today we'll see a little bit on how we can use this HVDC link to control the power flow. Okay, so we actually this HVDC link is also to use for controlling the power flow. So now you know that if you transmit the power through DC, okay, then it says it is much cheaper. When it will be cheaper is if the distance, if there is substantial distance, which means more than 500 kilometers, it says, okay, which means it will come a long transmission system or long transmission line. But it is most costlier for short transmission line. So you have learned that the classification of short transmission and long medium transmission line. But so now this HVDC link is mostly okay, it is advantageous and cheap if the distance is more, or so if there is a substantial distances, whereas for short distance, so it says a cost involved in this procuring or using this power electronics device will be much more than the profit you will get. Okay, so that's why in short distance transmission line you will not see this, but this is also another ways which we can control the power flow. Okay, so but when we talk about the HVDC link, so you might have learned about this. What are the different types of HVDC link? Okay, so you might have learned that monopolar, bipolar, and then homopolar link. And then even you will know this with the block diagram and all. But when we talk about the HVDC link, generally what do you understand by HVDC link? So when you talk about the HVDC link, basically you will have two parts. One is rectifier, another one is inverter. So why we need rectifier is because generation is in AC form. Then for a longer transmission line, it is cheaper to transmit using the DC KISS line. So then what we have to do is this AC has to be converted to DC or rectified to the DC. How it will be done is by using a power electronic device, and that device is known as a rectifier. And then towards the end, so this will be a DC line, and then you will get it, you transfer a DC voltage or DC current. And then towards the end, what we require is AC, load normally in the form of AC. So what you have to do is this DC has to convert back to the AC. So that how we will convert is using a power electronics device, and that is known as inverter. Okay, this is how we can use HVDC link to transfer the power in a transmission system. So why we are going for DC? For a longer distance line, it is much cheaper. Okay, because how it is cheaper is, so DC will have less losses than in the AC. Okay, so that's why it will be a much cheaper. Okay, so that's why, say here I have written that this HVDC link will consist of a rectifier and then inverter connected together. Okay, so why we need this? Already we have learned then power flows from the rectifier to inverter is effect transfer from rectifier AC side to the inverter AC side, which means here power flows from, okay, so normally, so from here, as soon as generation is there, okay, so AC generation, so you will try to rectify to DC, and then power will be flow transfer or flowed or transferred from this AC okay, so rectifier AC side, okay, to the inverter AC side, okay, and then this rectifier voltage will, let's assume that you might have done in the analog and digital electronics or some electronics related, so you might have done VDC, but here I have given VDCR, means a rectifier voltage VDC. This will play a very important role of the DC source, because from here it is a AC source. After conversion of this, okay, or rectifying, so we get a voltage VDC. What is the value of VDC? So you know that how you have to find the VDC, right? For a rectifier, so already you have learned. Even though you might have may not have learned using the thyristor, but you might have learned using the diode. So the VDC, only difference between the thyristor and diode is in thyristor we can control this firing angle, whereas diode you cannot control. Okay, so there, this is the only difference. So now this VDC will become a source or DC source for required for the inverter operation. Okay, so which means from here DC source will flow, and then this has become a source for inverter. Okay, so inverter operation, which means inverter will input to the inverter will be DC, and then output you will get is AC. So okay, from here AC to DC, and VDC is, we call it VDCR, is called it as a VC source or DC source VI, because for the inverter operation. And the magnitude of inverter and rectifier voltage is determined by the firing angle. So that's why how much you want to produce here, this magnitude of this inverter voltage will depend upon your firing angle, which means you change the firing angle and control the power flow. Or so what magnitude of the voltage means we are controlling the power flow. Okay, so this current or power can be changed by changing the magnitude either or both the voltages. So now what we can see is, so now here magnitude, whether you want high or low, it will depend upon the power and sorry, it will depend on current and voltages, or you can say as a power. Okay, so this how we can use. Okay, so now similar case, this is okay, it's just a same case I have shown here, and then so this block diagram can be reduced to a simple electrical circuit like this. Okay, so now from here one DC source we got, right, and then you start DC, and then here also we need a DC only, right? Inverter also we require a DC, but from here after inverter, so we have AC part. So here we have not shown electrical, but what we are doing is we are just showing from this transmission line system. Okay, so in this transmission line system, your source is DC because it has been converted AC to DC, and then towards the end also to function this inverter we require a DC only, so we can reflect it by DC, but actual case it will convert to AC, and this is how we can transfer the power using the HVDC link, or how we can control the power flow using HVDC link. Okay, so this all I have explained about this, you can just read and you know. Okay, so now classification of HVDC link. Okay, so when we reach to the classification of HVDC link, so I will not go that details since you have learned. Okay, so this HVDC link is broadly classified into following categories. Number one is monopolar links, another one is bipolar links, and then another one is homopolar links. So its application will remain as same. Okay, so here just I have not shown that the homopolar or monopolar or bipolar, just I have seen that rectifier and all. But actually this HVDC link is what they are doing is, example monopolar link here, AC, you are converting to DC, and then here it will be a transmitting a power through DC line, and then at the load system you inverting back to the AC. Okay, so this is a application of the HVDC link, but this is a basic classification of the HVDC link, and this is just a repetition of the power electronics application. Okay, so you can go through this, and in more detail you might have learned about the monopolar link and the bipolar and homopolar. Okay, so this another types of HVDC link. Its function will remain same and application is same. So from here, let's say AC source, and then it has to and then transmit using a DC transmission line or system, and then it has to be inverted or back to AC for a application. Okay, so similarly, another one is homopolar links. Okay, so you can go through these different types of HVDC link. Okay, so you have learned in the even in power electronics application. So now it is just a parallel one only. You are learning now, so it will be much easier for you. Okay, but these are the different types of HVDC link. Okay, so what is the use of HVDC link is actually HVDC link is used to control the power flow. Okay, so that's all about today's lecture. Okay, so in today's lecture we have seen that how to control the power flow using the phase shifter, and then another one is AC DC AC conversion, means it is same as uh, HVDC link, and then also we have seen the HVDC link, how it can be used to control the power flow, and then types of HVDC link. So here types of HVDC link, I have not gone that detail because you are you have learned, or I think power electronics application module tutor will be teaching this in detail. So now I to waste here. Okay, so here we will not see about the characteristic definitely. What we are seeing is we will see the application part of this HVDC links. Okay, so that's all about today's lecture. So if you have any doubt or any clarification to be made, so you are most welcome. It seems there is no doubt. So if you have no doubt, then one request to all of you. Okay, so now there is chances that there will be a face test also. Okay, through online. So now be prepared. Okay, so the syllabus contain and then all we may I may inform you, but be prepared about the face test. Okay, there is chances that there will be an online face test, and then tomorrow there is a ad hoc, and then we can say that emergency uh, college academic committee meeting directed from the OBC only, so RUV only, which we have to finalize this face test and all. So there is chances that face test may have to do online. Just now I'm not sure, but so it will depend upon tomorrow's outcome, tomorrow meeting's outcome. So please be prepared, and then if you have any doubt, you can ask. And then please, I'm reminding again, please prepare on this type of situation, at this type of situation, which means anytime they may call for face test, how to go about. Tomorrow they will discuss, and then so outcome will be, I think outcome will be shared to you all, okay, through the office of Dean Academic Affair. Okay, so that's all for today, and then be prepared about the face test. Okay, so class test is fine. It depends upon model tutor and ourselves, right? But face test is a centrally coordinated, which means so if it come as an office order, then there is no option we have to do. Okay, and then in such case, so to avoid the disaster, so normally most of you have a face disaster in the module, right? So to avoid this type of disaster, please be prepared. At least for power system operation and control, you need one, two. Okay, at least you need 1 and 2 or to some extent unit 3, but unit 1 and 2 is must to assess for the face test at least. Okay, so unit 2, and then but that syllabus I will inform you, but at least unit 1, 2, and then half of the unit 3 may also come. Okay, so please be prepared about the face test or test which Office of Dean Academic will announce. I think they will announce after tomorrow's meeting, and then I don't know, it will come as a timetable schedule, or it may give authority to the module tutor. Okay, so we are not sure about this. Okay, so just as a information I am sharing, and then it is not to be panic. Okay, so nothing to be panic here. So everything is same, almost same. Okay, so when we do a seminar online, so answer session will remain same as if you are presenting here also. Okay, so only difference is just one has become virtual and other you have to do a face to face. Okay, so that's all for today's lecture. So thank you for coming online, and then so next class we will see the real power scheduling. Okay, so thank you.
Thank you,
Thank you,
sir.
sir.